Alright, so in the last video on the Mercedes, I had a little bit of a mishap that I didn't show with the distributor rotor adapter, I guess you could call it, that goes into the end of the cam. They make it to where it rusts in there, and it's kind of press fit in there, and it doesn't come out. This is a redesigned one that's steel instead of cast, or machined instead of cast, and it's a little bit smaller, so I don't want to disconnect these pieces, but when you put it in there, it just slides in there. So that's how it should have been from the factory, because it's a distributor rotor, not a freaking like something important. And basically we used a tie rod separator to try to get this off, and we were doing it. It was late at night. You can watch the video, it was the last one. And we just broke the end of the cam off. Let me pull this piece off here. So as you can see, that's broken, and I have just recently made my first successful TIG welds, and I did already make a successful tack. You can see I keep melting my rod. I'm still getting used to it, and basically the idea here is to weld this on here and get it to be strong enough to hold a speedy sleeve, which is like a thin like, I think it's steel, like little thin for the seal to rest on, because there's already was a kind of a small groove in the metal already right there. I don't know if you can see that, it's kind of blurry, but I'm going to go ahead and weld this. Try to grind it down and put the speedy sleeve on, but if I can't, I'll just wait till next Friday. I'm in PMT machine shop class, so I'll do that in there on next Friday. And machine it down in the lathe, but it should work, and I haven't done a time lapse in a while, so I'm going to go ahead and do one of those while I try to weld this. Alright, well, somebody decided to text me during that frame lapse, so I wasn't able to show you, but here's the weld. Let it focus. You can see there's a hairline crack down the middle of it from the tension, but I got it tacked right there, and right there. Now I'm just going to burn it the rest of the way in, and hopefully nobody will text me this time. So the reason it wasn't doing that long of a video was because I had it set to 42 seconds. But anyway, there's my first TIG weld on steel, or whatever kind of cast material this is. It's very brittle, cracks a lot. So I went ahead and got a 7018, the last 7018 rod I had left for the stick welding ability that this welder has, and I layered in that little or big hole there that I broke a piece off of, and it didn't crack. And now I'm just gonna try to fill in as much as I can everywhere else without getting rid of the original shape of it too much, because I want to make sure that I don't have a wobbly speedy sleeve or repair sleeve. And yeah, so now I can actually do a real time lapse. Alright, so at this point I've touched my tungsten to the filler rod too many times, and I'm kind of out of tungsten. Slash, I don't really want to do any more welding to this because it's just a distributor rotor. So I'm going to go ahead and clean this all up really carefully, make sure it's not cracked too much, make sure it's strong enough, and then I'm going to put the speedy sleeve over it. The speedy sleeve is going to hold it in there most of the way anyway, and then I'm going to go ahead and start assembling the engine again on this Mercedes. Alright, so here's a quick look at the cam just before I put it in the car. I took it to class and got it machined, and as you can see, the welds did pretty good. It was really hard to machine it with the welds being as strong as they are, especially this cam material is very strong steel. But you can see I got the speedy sleeve on it now. Nice and shiny. It's going to seal great. And I only dropped it down from 82,000 or 1 inch 182 thousandths to 1 inch 179 thousandths, so the speedy sleeve still worked. And then I cleaned up the inside of it. I actually ended up hitting it with the TIG again. I got a foot pedal in the mail for it, and that helped out a lot with turning up the heat while I was welding. And you can see that that goes on there nice and clean and flush, and it doesn't move a lot. Just a little bit from the keyway being kind of sloppy. But yeah, that's going to work out great. Nothing's warped, nothing's destroyed. You can see it's got a little bit of a mark right here from the bearings on the steady rest on the lathe. But other than that, this thing is going to be perfect. So that saved like $400.